Good morning all. Last week we have studied about some interprocess communication like signals, semaphore and a message queue. Today we are moving on to pipes and a socket. These two are another form of interprocess communications. Here the pipe can be used for communicating between various processes working in same computer. But the socket communication can be used for communication between various processes in different computer system, and it also can be used for communicating between the various processes in the same computer systems. These are the outline of this session. Initially I'll give an introduction to pipe. Then I'll move on to the classification of pipe. The pipe interprocess communication can be classified into anonymous pipe and named pipe. After pipe we will move on to socket. Then we will discuss about socket communication. Here we will see how the communication can be achieved using sockets. And now we are moving on to pipe. And this pipe interprocess communication is also called as pipeline. And this pipeline is a mechanism for interprocess communication using message passing. And in order to understand this pipeline or pipe, we have to first understand the standard streams of a process. In order to give and take the output and input to a process, we have three streams. First one is standard input stream or STDIN, and then standard output stream or STDOut, and then there is standard error stream or STDERR. And the standard input stream containing all the information which is needed to write into the process, or the information which is needed for the process is given in the standard input stream, and the standard output stream containing the output value of the process, and the standard error stream containing the error information of the process. And in the case of a pipeline, we will connect this standard input, standard output and standard error stream in a serial fashion, and which you can see in the next slide. Here we can see there are three programs: program 1, program 2 and program 3, which is connected through a pipe. Here there is one pipe, and there is another pipe. So there is two pipes, pipe 1 and pipe 2. And the standard input stream of the program 1 is the keyboard, because the program 1 is executing from the terminal, and the entered values in the terminal is given to the program 1, and here the keyboard acts as the standard input, and the input from the standard input is given to the program 1, and this program 1 will generate the output and error streams. The error stream is directly connected to the display, and if some error happening in the program 1, then we will see that that error in the display, and the output of the program 1 is given as the input of the program 2. Here the program 1 output and program 2 input are connected together. Here the program 2 input, here the program 2 input is nothing but the output of the program 1. So the program 2 standard input stream will be same as the program 1 standard output stream, and similarly the program 3 and program 2 are connected together. Here the program 3 standard input stream is same as the program 2 standard output stream. So whatever the values which is generated by the program 2 act as the input to the program 3, and the final output of the program 3 is displayed in the display, and all the error stream also directed to the display. Here these three programs, program 1, program 2 and program 3, which are executing simultaneously. And this form of interprocess communication can be achieved using either anonymous pipe or named pipe. In the case of anonymous pipe, data written by one process is fed by the operating system until it is read by the next process, and it is unidirectional and the channel disappears when the processes are completed. And the syntax for this anonymous pipe is like this: process 1 is separated by a vertical bar, then process 2 separated by a vertical bar, then process 3, like that. And these two symbols are called pipe. So this process 1 output will be redirected to the process 2, and process 2 output will be redirected to the process 3, and process 3 output will be displayed on the terminal. And the next type of interprocess communication is called named pipe. Here messages are passed to or from a pipe that is named by making it a file and remains after processes are completed. Here it is saying that the named pipe is a bidirectional communication method, but the anonymous pipe is a unidirectional communication method. We can understand the concept of anonymous pipe using this example. Here you can see there are three commands: command 1, command 2 and command 3, which are separated by anonymous pipe, pipe 1 and pipe 2. And here in the second command there is two words. First one is grep and then embedded. This grep is the command, and this double quoted embedded is the string. And the first command ls will list the names of the files in the current directory. So if you type the enter in a terminal, ls in a terminal, we will get the list of files in that present working directory. Then the grep command, it is nothing but a search command. It will search the input containing specified string. Here in this case, this grep will search the input containing the string embedded, and if the input containing the string embedded, it will print the input in the display. And the last one is the head command, and this head command will print the first 10 lines of the input. So in this total scenario, here in this example, we will get the output as here the output will be the first 10 file name with the name containing embedded string. So if we type in this format in the terminal, in a Linux terminal, we will get the first 10 lines, first 10 file names with the name containing embedded string. And this is an example of anonymous pipe, and this is unidirectional. Here the data is flowing from left to right. Here, in other words, the data is flowing from ls to grep, then grep to head command, likewise. In order to extend the features of the anonymous pipe, we used a named pipe. It is another classification of the pipe, and this named pipe is also found in Microsoft Windows, but the anonymous pipe is only found in Unix and Unix-like operating systems such as Linux and Mac operating system, but the anonymous pipe cannot be found in Windows operating system. And unlike anonymous pipe, a named pipe can last long as the system is up. It can be deleted if no longer used. It means that anonymous pipe is exist only when the process is running. When the process goes down or process terminated, the anonymous pipe no longer will exist. But in the case of named pipe, it will exist after the process is terminated, and we can delete this named pipe whenever we need it. And in a Unix or Unix-like operating system, this anonymous pipe will be found as a file. Now we can go through the example of named pipe. In Unix or Linux, we can use the command mkfifo to create a named pipe. Here we are creating a named pipe, example pipe, using the command mkfifo, and later we use that pipe to communicate between two commands. Here the commands are echo and cat command, and the communication between these two commands or these two processes is obtained using the named pipe example pipe. Here initially the echo hello world, this command will write hello world string to the example pipe, and using the cat command we read the content of this example pipe and display it in the terminal. In the last slide, we have studied about named pipe in Unix or Unix-like systems. Now we are moving on to the named pipe in Windows systems. In Windows systems, a named pipe can be created and accessed using create file, read file, and write file and close handle functions. Now let us move through the features of the named pipe. A named pipe can be used for intermission and intra-machine inter-process communication, and it supports full duplex mode and half duplex mode of operation, and it is also support byte oriented and packet oriented data transmission, and it is a reliable communication method, and it also a connection oriented communication method. So since it is a connection oriented communication method, it is a reliable communication method, and it allows blocking and non-blocking read-write operations, and it support standard device IO handler such as read file and write file, and we can use the namespace to create these handles. In this session, so far we have studied about pipe or pipeline. This pipe interprocess communication is used for communicating between various processes in a computer system. But it cannot be used for communicating between various processes which is working on in different computer systems. For that purpose, we are normally using socket. And using the socket communication, we can achieve the communication between various processes which is working in various computer systems. And a socket is represented as an internal endpoint for sending or receiving data within a node on a computer network. And it is more like a software counterpart for the physical socket. And using this socket, we are achieving the communication between various computer systems. And normally a socket is referred as a TCP IP socket, and it is a connection oriented protocol for communicating between various computer systems. And for addressing each socket, we have a socket address, and this socket address is unique for each processes, and depending on the socket address, the process can be selected and communicated each other. Here we can see a simple socket communication situation. Here there are two PCs, PC1 and PC2, and in these two PCs there are two applications are running, application 1 and application 2. And suppose the application 2 is a server and application 1 is a client. And this application 2 will create a socket, and it has a socket address of 146.86.5.20 colon 80. It is an HTTP socket, and this application is a server. So the application 2 will create a server socket and it will listen on this address. So suppose the application 1 want to communicate to the application 2, or the client want to communicate to the server. Then the client will create a socket, and its socket address is 192.191.28.15 colon 1500. And using the internet, the client will communicate to the server using the socket address. And the internal operation of this network communication methods can be understood by this image. Here you can see there are two applications, application 1 and application 2. And these applications are running in user space, both the client and server, which are running in user space. So since both applications are running in user space, they cannot access the networking hardware which is needed for the communication. So the application, initially the application 2, which is running in the user space, will ask the kernel to create a socket. So the kernel will create a socket using the API given by the kernel, and it will assign a socket address, and it will start listening on that socket address. In the meantime, the application 1 will create a socket using the socket API provided by the kernel, because the application 2 cannot access the hardware because it is running in user space. So application 1 has to call the kernel API for creation of the socket, and after creation of the socket, the application 1 will connect to the socket of the server using the server socket address. After connecting the socket with the of the server, the client and server can be do the communication each other. Our application is working in user space, so these applications cannot access the network interface directly. So in order to access the network interface, the kernel is providing some APIs or some application programming interface, and using this API, the application is accessing the network interface, and this API for accessing the network interface is called socket API, and the programming which utilizing this socket API is called socket programming or network programming. For communication between two different processes which is working in different devices, it should need a socket address, and this socket address is composed of both IP address and port number, and this IP address is unique for every device. So there is no two devices in a network has same IP address. If two devices in a network has same IP address, then the communication won't be possible. And this IP address is the short form of Internet Protocol address, and it is a numerical label assigned to each device connected to a computer network. And we can see an example of IP addresses 192.168.1.1. This is normally used for assigning IP address to a router, and if a computer connected to the router, the computer will get another IP addresses 192.168.1.2 like that. And for the socket address there should be a port number also required, and this port number represent a communication endpoint, and it is a 16-bit unsigned integer number. So the value of this port number can ranging from 0 to 65,535. So port number can take any value from 0 to 65,535, and some port number are reserved for some applications. For example, the port number 80, which is reserved for HTTP protocol, and for port number 443, which is reserved for HTTPS protocol. Likewise, some port number under 1000 is reserved for some applications. Now we can see some examples of socket address. In the case of Google DNS server IP address is 8.8.8.8, and the port number which is used for DNS application is 53. So the socket address of Google DNS server will be 8.8.8.8:53, and using this socket address we can contact the Google DNS server and do our task. And in the case of our modem or router in our home, the IP address will be typically 192.168.1.1, and the port number for modem interface is 80. So we can, using the socket address 192.168.1.1:18, we can contact the router configuration page and we can do the necessary modifications. Now we are moving on to various types of sockets. The network socket is classified into three types: datagram socket, stream socket, and row socket. In the case of datagram socket, it uses the UDP protocol for communicating between various processes. But in the case of stream socket, we are using TCP socket for communication between various processes. And now we can look into the various features of each types of socket. The datagram socket is a connectionless socket. So we can transmit data through datagram socket very easily. In order to transmit the datagram socket, we don't need to initially create a connection. But since it is a connectionless socket, the reliability is not guaranteed. And the second type is stream socket, and here it is a connection oriented socket. It means that it will guarantee the delivery of the data, so it will have a higher reliability than datagram socket. And for guaranteeing this reliability, it uses TCP protocol for communication, or transmission control protocol for communication. And in the case of row socket, it will send the data directly without any protocol specific transport layer formatting. Now we can move on to the socket communication. The socket communication is a method for communicating between two processes, and this communication is achieved using the socket address associated with the process. Here you can see there are two processes, a client process and a server process, and a client process has an associated socket address and a server process has an associated socket address. And here this client and server are communicating through the socket with the help of these two socket address. And here they are creating the communication using the stream socket. It is a connection oriented method for communication. So initially the server which will create a socket in the server side, and it will bind the address, socket address, to the server socket, and it will then start to listen to the socket address, and if some connection arrived, it will accept and start the sending and receiving of operation, and finally it will close the socket. And in the client side, it also need to create the socket. After creating the socket, it doesn't need to listen to the socket. Instead of, it will connect directly to the server socket using connect API, and then it will start read write operation, and finally it will close the socket. Now we can move on to the socket communication in detail. The first step for socket communication is to create the socket. Here we are creating the socket file descriptor using the socket function. Here socket FD is the socket file descriptor, and using this socket FD we can later bind the socket address and start the communication. So managing the socket is made possible using this socket file descriptor, and this socket file descriptor is obtained by creating the socket using socket function. And for the, as a parameter for socket function, we are giving domain, type and protocol, and this domain specify whether we need IP version 4 protocol or IP version 6 protocol, and this type specify whether a TCP connection is need to be created or UDP connection need to be created. After creating the socket, the next step is to bind the socket with an address. For binding the socket with an address, we are using the bind function, and for the parameters for bind function, we are giving the created socket and the socket address. So the bind function will bind the socket with the socket address, and the next step is to listen. So our socket will listen for the incoming connection and then accept and connect. The next step are accept and connect, and this will connect the server socket with the incoming client socket, and after connection we can send and receive data to the client socket. In the case of client, we don't need to listen for the incoming connection because we are directly connecting to the server. So after creating the socket, the next step is to connect to the server. Here the connect method will for the parameter to the connect method, we are giving the socket address and created socket, and then we will send and receive data through that socket, and finally the closing of the socket. So it is more simpler than the server socket. So far in this session we have discussed about pipe and socket. Pipe is a simple interprocess communication method, and it is mainly used in Unix and Unix-like operating systems. And this pipe interprocess communication method is classified into two: named pipe and anonymous pipe. And we have seen some examples of these two types of pipe. Then we moved on to socket. And socket is a special type of interprocess communication which is used for communicating between different systems or different processes which is working in different systems. And in order to identify the processes, we are using a socket address, and we have seen the format of the socket address. Then we have seen the basic operation of the socket communication in server and client. Now I am going to wind up this session. Thank you for listening. See you tomorrow.